Hello, Mr. Mailer here, online math teacher, and welcome to my channel. Today we're going to be continuing my video series on hypothesis testing, and in particular, we're going to look at how to do a one-sample t-test for population mean. And this is part one of 2 videos. I'm going to show you how to do with an example for a one-sided alternative hypothesis in this video. So let's jump into it. So if you're doing this, you're going to use the 4-step process, and this is going to be the same 4-step process you used when you made confidence intervals. So it's going to use the state, plan, do, conclude framework. So state, what's the hypothesis you want to test, what significance level do you want, what are the parameters you're going to use, and what is your sample statistic. Then the plan phase, just like before, is going to have choosing an appropriate inference method and checking your conditions. The do is, if the conditions are met, perform your calculations here. And those are going to be a test statistic, as well as a p-value. And then conclude, interpret the results of your test in the context of the problem. So this is very similar to confidence intervals. So let's look at an example. So we have a one-sided alternative hypothesis today in this video. So supposedly, on average, an hour-long television block should expect 15 minutes of commercials. You are skeptical that this claim holds for your favorite channel. You believe that an hour of television will have more than 15 minutes of commercials on average on this channel. So you're going to conduct a test. To determine the average minute of commercials on an hour-long television block on your favorite channel, you randomly select 15 different hours during the next week and record what your favorite television channel plays in each of these 15 hours. So you're dedicated here. Here are the numbers that you get. This represents how many minutes in each of those hour-long blocks that played commercials. So, what should you conclude from this? Well, we're going to carry out a hypothesis test for this. So, you're given data in this example. You don't necessarily know what your mean and your standard deviation are. You'll have to compute those. So, sample standard deviation is the formula you use here. This is a sample, remember. So, state, hypothesis, significance level, parameter, statistic. We want to perform a test with a significance level of alpha is equal to 0.5. So when it doesn't tell you a significance level, we tend to default to alpha is equal to 0.5 as our significance level. So I use that here. Our null hypothesis is that the true mean number of commercial minutes in an hour-long block is just going to be 15, because that's what the typical claim was. But you think it's more than 15, so your alternative hypothesis is mean is greater than 15. And you define it where mu is the actual average minute number of commercial minutes in each hour-long block on your favorite channel. And here I computed my mean and my standard deviation. You'll probably use a calculator or some sort of technology for this. So this is everything you need in state. We got to go to plan. We got to choose our appropriate inference method, and we got to do our conditions. So we're going to use a one-sample t-test for population mean mu. That's what we're going to do if our conditions are met. So again, just like before, conditions are really the same as they were for confidence intervals. Is your data random? In this case, yes, we took a random sample of 15 hours, and this is what will let you to generalize what your observations from your sample are to the population. So this is inference. Independence, so things like the 10% condition. Yes, 15 hours is less than 10% of how many hours there are in a week. So we have the 10% condition satisfied, so simple random sample is fine to take here. Independence is satisfied, and we can use our standard deviation formula for the sampling distribution of x bar. Now, do we have normality? Well, it's tougher here. We don't necessarily know what the population distribution looks like, but we have all that data. So when you have data, and it's not a large number, because we didn't have a lot, so I can't apply the central limit theorem, I can just make graphs. So I made 3 graphs here. I have a dot plot. Looks fairly symmetric. I made a box plot. Okay, still fairly symmetric. No outliers here. I don't have any dots. You'd assume it's modified. And then I made a normal probability plot, and everything, it looks fairly linear. So all these are indications that the population distribution is roughly symmetric, roughly normal. So because of that, all these graphs indicate that we don't really have a strong skew. They're roughly symmetric with no outliers. Then we conclude the population distribution is roughly normal. So that means our sampling distribution is going to be roughly normal. So if you have a large sample, go central limit theorem. Don't make these graphs though, but we didn't have large data here, so we had to look at graphs. So we have normality. So our conditions are met. Now we can go to our do phase. So we got compute a t-statistic, or a test statistic. Sorry, I don't know why I want to keep calling it t-statistic. So choose a simple random sample size n from a large population that contains an unknown mean mu. And then we're testing our hypothesis. So your t-statistic is going to be your statistic minus the parameter divided by the standard deviation of the statistic. So in this case, your sample mean minus our claimed mean in the null hypothesis divided by the standard deviation, or you can think of a standard error, whatever you really want to think about it as. We're using our sample standard deviation and the fact that our sample size is n. So, and p-value, you're going to need to use your t-statistic as well as the degrees of freedom. And this is going to be your sample size minus 1. So n minus 1 is going to be your degrees of freedom. And we only use these tests, again, when we satisfy those conditions on the previous page. So if we go to compute these in our problem here, and again, we know we're interested in this picture to the far left. This is a one-sided alternative hypothesis. We're interested in greater than t here, because we think that the hours are more than 15 minutes of length. So test statistic, I take all my data, plug it into my formula, and I get a t-value of 4 here. So that is my test statistic. Now I can go use that to help find the p-value. Our sample size 15, so minus 1 gives me degrees of freedom of 14. So I have this picture here that I'm looking at. So I go to my table. I look in my table to find a degrees of freedom of 14 for that row. A t-value of 4 is between 3.787 and 4.14. And those correspond to areas in these tails, or probability being 0.001 and 0.005. So your p-value is going to be somewhere between these two values. So this is the table you'd have on the AP Statistics exam. If you don't want to know it's just between two things, maybe you want to be more precise, you can use technology. The following is what I would use in a TI-84 to get that this area in the tail is actually 0.0006, and that matches up with what our table tells us, because that value is between these two tail areas up here. So you can use either your table, or technology is probably a better option here. So now that we have everything in the do phase, we can go to conclude. So again, we always compare our p-value to our significance level alpha. Well, since our p-value of 0.0006 is less than the significance level of alpha is equal to 0.05, then you should reject your null hypothesis and accept the alternative. In the context of our problem, that means we should accept the alternative hypothesis, which states the actual average number of commercial minutes in each hour-long block of television on your favorite channel is greater than 15 minutes. We have substantial evidence to support this. And if you're wondering what it might look like written out, because you're not going to make a PowerPoint, this is my done out version of this that I would have done by hand. You didn't necessarily need to make every graph like I did there. I just stuck with a dot plot here, but you can look at a bunch of different graphs that can tell you some good information. So I hope you found this video helpful. If you did, consider liking and subscribing, and have an awesome day.